Okay, viewers, welcome to Project Labs. In today's edition, we are going to go through basic theories and then introduce ourselves to a system of putting components together to build electronic circuits. I'll first introduce us to the very basic components that we need in order to have successful practical at home. In electronics, when you have these components available in the house, you can have a very successful practical at the comfort of your own home. These are, you need a cable stripper. This will help you be able to strip a cable and then be able to use it as a jumper. You need source of EMF, which is the dry cells, 9 volt battery I have here, and then the terminal to connect to the circuit. We need some electronic components, very basic ones, like this is a transistor, uh, resistors, diodes, light emitting diodes, and then variable resistors. I also have a couple of wires to be used as jumpers. I have a multimeter to test components, and then the last but not the least, the breadboard. In fact, I'm going to talk much about this because this is the basic tool that we need to be able to build a successful circuit at home. And this is meant for people who are introducing themselves to electronic practical. So, without wasting time, we are going to go through the very basic uh, usage of this tool. Okay, so breadboard, as the name applies, is a solderless system of connecting components. Instead of twisting these components together in order to create a circuit and then putting them together by twisting, it's not going to be very helpful. Because of that, this board has been developed to help join components together in order to have a successful practical without damaging the components. Because if we should solder the components together by using soldering iron and then the lead, it will make it difficult to desolder and then use again, or by applying heat, it make it difficult to reuse the component. So the breadboard makes it easy for a novice or somebody who is now introducing himself to electronics. Now, as we can see the vertical dots here, all these vertical dots are connected as one terminal. So from the top to the down is connected as one terminal. But in the rows is not connected. There's no connection from this to this. This is one terminal, this is also another terminal. Likewise, this and that. It continues to this end. This is a gap, a bridge, meaning there's no connection from here to here. There's no connection at all. The same applies to this place too. These are all connected as one, but there's no connection from this row to the next one. There's no connection. So when I slot in a component here, and then I slot in here and here together, what it means in electronics or electricals is short circuiting. Short circuiting because I've connected one terminal of the component to this place and then the next terminal to the same place, means I've short circuited the component. It is not good, it's very wrong to do that. So if you want to put this component in circuit, You connect one terminal to this and then another terminal to this. It's okay. You can connect from here to here or any other slot. It's okay. All right. And then the next one is this. All these are connected horizontally. It's connected this way to this point. And there's a bridge here again. And then it continues from here to the end as one terminal. But there's nothing in relation to this and that because this is one terminal and the next vertical is the next horizontal is also another terminal from here to here. All right. So if you connect a component, let's say from here to here, from this slot to this slot, it has not been short-circuited because there's nothing connecting this column to the next column. There's nothing related to that. But should you connect from here to here, it means you have short-circuited the component because the terminal runs through to this point. Okay, so the same applies to this section and the same applies to this section up to here and from this section to here. If I want to connect this section to this section, I just have to put in a jumper from here to here and then that will be connected. All right, this is normally used for a power line and then a neutral line normally. Okay, so we are going to slot our components in here. When you look closely, you see that there are labeling from A, B, C, D, E, F, G, H, I, J. And then there's a labeling here in terms of numbers 1, 5, 10, 15, 20, and so on and so forth. So you have to follow carefully so that you have your work done successfully. Now I'm going to build a very basic circuit. Let's say resistors in parallel. Let me take three resistors in parallel. Three resistors in parallel. So for three resistors in parallel, we know that resistors are said to be in parallel if their terminals are connected at one point and connected at the other point. So let me see, this resistor is in this circuit, in this slot. Okay, then I take the next resistor. I'm using 1K resistors. 1K resistors. All right. Then I connect the next one here. So these are three resistors. They are not yet in circuit. I've not put them in circuit yet. So what I have to do is to connect this terminal to the next terminal and this terminal to the next terminal. This and that also connected together. Then I'll have these three resistors in parallel. So what I'll do is I'll use the jumpers for that. So I'm connecting one section. We should connect it at the right point. Okay, then connect from this point to this point. Okay, then from here. All right, so now that these jumpers connect to from one resistor to the next and to the next, then these three terminals are all joined together. It's just like twisting the three terminals together. That applies to this as well. This terminal is connected to this terminal and also connected to this terminal. It's the same as joining these three terminals together. This can be done in various ways. In fact, we can as well take three resistors like this, slot in here, and then slot in here, and then slot this one to here. So I've connected the same thing here. Three resistors connected in parallel here too. The reason being that all these terminals are one, connected as one. Internally, they are connected. And here is also connected internally. So all the uh, vertical lines you see here, or vertical dots we see here, are all connected as one terminal. The reason being that it gives the option for several connections, or it gives ports for several connections.